Alright, we are looking at page 284, 11-7, Transformations and Congruence. So the question starts off here. What are congruent figures? Miss Salugia makes stained glass windows. She wants to make two triangular windows that are congruent. So you need to know that congruent figures have the same size and same shape. So how can you tell if the two windows are congruent? That's the question. Alright, look on page 285. You want to start by comparing the measures of the angles and the sides. Okay, so in congruent polygons, corresponding angles are congruent and corresponding sides are congruent. So let's look at the figure, the example. Alright, so let's compare the measures of the two windows. Corresponding angles are congruent. So if I looked at these two windows, I have here a 50-degree angle, two 50-degree angles, and down here I see two 50-degree angles. So the corresponding angle to angle M would be angle B, and they both have these 80-degree angles. So angles are corresponding and they have the same, are congruent. And then we'd look at these sides. So line segment AB here would then correspond with line segment LM, and they should measure the same, which would be 14 inches. That means LN, line segment LN, would correspond with AC, and they should have the same measure, which is 18 inches. And then the same would go for MN, line segment MN, and line segment BC. They should also have the same measurement or be congruent. This would be the congruent angle, corresponding angles being congruent and corresponding sides being congruent here. Okay, on page 284 we're looking at some basic transformations. So a transformation, here's the definition, moves a figure to a new position without changing its size or shape. So we have four transformations here. We have a translation. So this moves a figure in a straight direction. So here is the example. We had this green figure, and it moves in this straight line. It's kind of like up and to the left. And this translation, if you were going to describe it, you could say it was 4 units up and 4 units to the left and 3 units up. Now, how you can. All right, we're looking at 284. What are some basic transformations? And they have 4 here. So a transformation moves a figure to a new position without changing its shape or size or shape. So here our first one is a translation. Okay, so this moves a figure in a straight direction. So the green figure is moved up here, kind of angled up and to the left. And if you're going to describe that translation, they have it down here. They say that it's a translation 4 units to the left and 3 units up. And the way you could tell or explain the translation is use a point on the green figure, and then use the same point or corresponding point on the other figure. And you can see that it moves to the left 1, 2, 3, 4 units, and then up 1, 2, 3 units. Okay, and that's a translation. A reflection of a figure gives it a mirror image over a line. So it's like it's just been flipped over this line here. This is a reflection over a horizontal line, they say. So it's like it's been flipped over, and it's not a translation where it would be slid straight down. Okay, that's not what happens, because if you look at it and you look for your corresponding angles, this angle would be corresponding to this one. So it's like it flipped right over that line. Alright, and here we have a glide reflection. This is a translation followed by a reflection. So here the green figure moves straight down, okay, to right here, and then it's flipped over or reflected over that vertical line. Vertical lines are up and down. Okay, and the last one is a rotation. So a rotation moves a figure about a point. So say we were going to use this point right here. This line was facing down, and after rotation it is facing this direction. So I could talk about the type of rotation. Okay, I can say, well, it moved clockwise, like the hands on a clock. I can talk about degrees or use fractional terms here, but if I look at this angle, I could say, well, this is a right angle. So this was a 90-degree turn, or if you look over here, a 1/4 turn clockwise. And here it shows some examples. If this was the original shape, and we said this is the point that it turns about here, or rotates about, it shows you how much is this would be a 90-degree turn. Well, look, I'm comparing this line to this line. Here's 90 degrees. Okay, and when it rotates all the way to right here, well, here's that same side, and there's an 180-degree straight line, or half of a turn before it's all the way back to itself. Here, when we get to this point, it's rotated 270 degrees, or 3/4 of a turn, and then once it's back here, it's rotated a full 360 degrees, a full turn. All right, look on page 285 at the guided practice, and I want you to do all of it. 1 through 4, it says use the congruent triangles for these questions. So triangle ABC is congruent to triangle XYZ. Now, so corresponding angles are congruent, so use that, and corresponding sides are congruent. Use that to find the measure of these angles it asks for and the line segments, and then answer the questions 5, 6, and 7, and bring them to class tomorrow, and bring any questions that you have, and I'll see you then.